down to chlorines. And the chlorine floats loose in the stratosphere, and it searches around for an ozone molecule. And chlorine atoms are very, very hungry to try and find other atoms that they can mate up with. And so when they come close, they can pull loose from the ozone, leaving behind a plain old oxygen atom that doesn't absorb much UV radiation, and create temporarily something called chlorine monoxide. This is a fairly unstable compound which floats around until a free oxygen atom happens by. And when a free oxygen atom comes close enough, the chlorine comes loose very easily and forms a stable oxygen molecule. The chlorine, meanwhile, is free to roam on and to look for more and more ozones that it can break up. This one chlorine atom can break up as many as 100,000 ozone molecules before it finally retires. So let's summarize what happened. We started out with an ozone that was up in the stratosphere, and a CFC came along, gave up its chlorine, and that in turn ended up producing two stable O2 molecules that no longer absorb UV radiation like the original ozone did. You see, the chlorine can be a bad actor in the stratosphere. Scientific evidence collected over the last 20 years has supported the idea that CFCs are the primary cause of ozone depletion. In particular, the chlorine levels and fluorine levels have tended to go up together, which is what you'd expect from CFCs in the atmosphere. And measurements in the stratosphere have shown more CFCs, more chlorine, and more chlorine monoxide. If you compare this to the kinds of natural emissions from volcanoes, there's a totally different pattern. The net result is that worldwide consensus has come to form that this is a global problem, that everyone has to pitch in together in order to reduce these CFC and HCFC emissions. We've looked into molecules and atoms, and we've seen that CFCs are the source of a potentially major problem. Now let's take a look at what transpired in the legal realm. How did we get to the point where we have certification? If you start back in the early 70s, just really a couple of decades ago, you'll find that scientists worldwide were concerned about ozone depletion and developed a theory early in the 70s that proposed that CFCs were the cause of the problem. It gained sufficient worldwide attention and agreement that by the late 70s, in 1978, the US banned CFCs in any non-essential aerosols. And that set the stage for nations worldwide to get together to try and form an agreement as to how they could control CFCs and gradually eliminate their use. As a result of the worldwide attention given to the depletion of the ozone layer, in 1987, 22 countries got together in Montreal, Canada, and signed a treaty agreeing to reduce the production and to reduce the emission of CFCs worldwide. In order to be quantitative, they established something called the ozone depletion potential. The ODP is a measure of any refrigerant or other material's ability to damage the ozone layer. They divided things up into two major classes. Class 1 consists of CFCs, which we've heard about, of course, and halons. Halons are chemicals that are frequently used in computer rooms and for fire suppression in computer rooms. CFCs and halons have very high ODPs. In addition to the ODP, they defined something called the GWP, the global warming potential. The GWP is different from the ODP. That is, it measures a refrigerant's or some other chemical's ability to increase global warming. Work in 1987 didn't end. Countries continued to work together, and in 1990 and in 1992 they amended the Montreal Protocol to include other substances like HCFCs. Class 2 covers HCFCs, and these are also going to be phased out, although because they're much less harmful, they're allowed to exist and be produced for longer periods of time. On November 15, 1990, President Bush signed into law the Clean Air Act amendments. This law had several important results. It established for our country our response to the worldwide concern. And in particular, it ceased venting of CFCs and HCFCs according to an important schedule, and it also set limits on time schedules for production. Under the Clean Air Act, the EPA issued regulations that will help us to ultimately eliminate the use of CFCs and HCFCs. The schedule for reduction of CFC production is that production will decline through 1995. Until after December 31st, 95, no CFCs will be produced at all. This, of course, means that if CFCs are required for an existing system, they're either going to come from recycled, recovered, or reclaimed refrigerant. A second important schedule for reduction is in the production of HCFCs. In a similar way, those tail down to zero in the year 2030, so they'll be in use much longer. Two more important dates that have come out of the Clean Air Act are regarding venting of refrigerants in the atmosphere. After July 1st, 1992, you cannot knowingly, legally, vent either CFCs or HCFCs. And after November 15th, 1995, you cannot knowingly vent alternate refrigerants, such as HFCs. In the real world, of course, there are situations in which some amount of venting takes place and it can't really be prevented. Those real-world situations are recognized by the Clean Air Act by having three types of releases that are permitted, and the only three that are permitted under the legislation. Number one is that you can have what's referred to as de minimis, which means the minimum quantity of refrigerant released. And that's when you're making a good faith attempt to recover, recapture some refrigerant. The second is in the normal course of operation for equipment, some amount of leakage may occur, and that is permitted. However, you should note that the EPA does have requirements that we'll discuss in a minute about repair of substantial leaks. And the third legal kind of release is if you're using nitrogen and R22, either as a holding charge or for leak testing, that's legitimate, as long as the R22 is not being used as the refrigerant. Under what is called Section 608 of the Clean Air Act, the EPA is required to issue regulations that will carry out the Act. And in particular, there are 5 main requirements for recycling, for emissions reduction, for disposal of what are called Class 1 and Class 2 substances that have been released by the EPA. The first of these
is called service practices. And here, technicians that are servicing and disposing of air conditioning and refrigeration equipment need to observe certain practices. The most fundamental, the first and most important that will run throughout our entire tape is that there's a requirement to recover refrigerant rather than to vent it to the atmosphere. Any venting that takes place with the knowledge of the technician is considered a violation of the Act. Technicians, the second part of service practice, a technician is defined by the EPA as anybody who performs maintenance, service, or repair to air conditioning or refrigeration equipment and could reasonably be expected to release CFCs or HCFCs into the atmosphere. An installer, a contractor, an employee, somebody disposing, in some cases even the owner. And third, under service practices, before any air conditioning or refrigeration equipment is opened for maintenance, for service, for repair, the refrigerant in either the entire system or that part that's being serviced has to be transferred to a system receiver or a certified cycling recovery machine before the service is actually performed. The second major EPA requirement is concerning technician certification. Anyone who has the reasonable possibility of venting CFCs or HCFCs into the atmosphere must pass an EPA-approved certification test by November 14, 1994. Or, after that date, they won't be able to purchase Class 1 or Class 2 refrigerants. You're going to have an ID card. You can, of course, have runners who go over to a wholesaler to pick up and return with CFCs, but you'll have to make arrangements with the wholesaler beforehand to have your certificate on file. And it's also your responsibility to be sure that you've informed the wholesaler in case the status of any of your runners changes. In order to become certified, you need to pass an exam. It has 4 parts. The first part is a section on a core of questions on stratospheric ozone protection. There are 25 questions there. And then each of the other 3 sections have 25 questions each. You have to get 70% right from each section in order to pass the section. If you pass all 4 sections, then you're called universally certified. Now, the different sections are Type 1, Type 2, and Type 3. Type 1 is for small appliances. And here's where it's important to go into the definition of small appliances. An appliance which is manufactured and charged and hermetically sealed with 5 pounds or less of refrigerant is a small appliance. That can be a refrigerator, freezer, room air conditioner, packaged unit, whatever it may be. Type 2 is for high pressure appliances, and there are really 2 parts there, high pressure and very high pressure. High pressure is appliances that use refrigerants that are between minus 58 degrees Fahrenheit and 50 degrees Fahrenheit. That is, that the boiling point is between those 2 temperatures. That might be R12, R22, R114, R500, R502. And the other part of Type 2 is what are called very high pressure appliances. And those that have, those are refrigerants that have a boiling point below minus 58 Fahrenheit. And that might be R13 and R503. Last is Type 3, which is low pressure appliances that uses a refrigerant with a boiling point that's above 50 degrees Fahrenheit. That might be R11, R113, R123. And remember, if you pass all 4 sections of the test, then you're universally certified. Or if you pass the core section plus any of the others, you're certified for that particular appliance type. The third important part of EPA requirements is equipment and reclaimer certification. Before you can open a system for maintenance, service, or for repair, you must evacuate the refrigerant from either the entire unit or the part that's being serviced to a system receiver or to a certified recovery or recycling machine. And there are vacuum levels that you have to meet, and those we're going to be covering in the next section of the tape. You must have on hand a certified recovery machine, and you must certify to EPA that you have one. There are, again, requirements about the machine that depend on its manufacturing date, November 15th, 1993 being an important date there. But we'll get to that soon also. Refrigerant cannot change ownership unless it has first been brought up to the purity standards of ARI Standard 700. And that's an important standard to remember because it specifies what has to be the minimum levels that have to be reached in order for refrigerant to be reclaimed sufficiently to be redistributed. The fourth major requirement from EPA concerns leak repairs on systems that contain more than 50 pounds of refrigerant. Those systems that are industrial, process, and commercial refrigeration equipment that have an annual leak rate of 35% or greater must be repaired. All others, if they have an annual leak rate of 15% or greater, have to be repaired. And you know, it's important to note that it's the owners of commercial and industrial equipment that are responsible for the record keeping of refrigerants added to their equipment. The fifth major requirement from EPA is that equipment and appliances have to be able to be disposed and dismantled of safely. That is, that the refrigerant can be removed. And so they require that refrigeration equipment has to have service apertures, as they're called, valves and so forth, that make it easy to extract the refrigerant from them. Small appliances have to have what's called a process stub in order to have easy access. And last, the EPA requirements note that the final person in the disposal chain, that is the person in the scrap metal yard, is the one that's responsible for seeing to it that the refrigerant is recovered, or they need to obtain some kind of verification that the refrigerant has been removed. In addition to these 5 main requirements from EPA that we've just outlined, there are several record-keeping requirements that the EPA has set up to help with enforcement of the Act. The first, of course, is that the equipment that's used for recovery has to be certified. Technicians who are providing service on equipment that's 50 or more pounds of refrigerant have to provide an invoice stating the amount of refrigerant added. Reclaimers have to keep records of the names and addresses and quantities of refrigerant that have been sent to them for reclaiming. Contractors and other recovery and recycling equipment owners have to certify that they have the proper equipment. Disposers have to maintain copies of the statement saying that the refrigerant was recovered from the equipment they're disposing of. Any certification programs, such as ACCA's, have to maintain records of name, address, and the scores of persons that are certified. And wholesalers have to be able to keep invoices showing who purchased what CFCs and HCFCs. And last, owners and operators of commercial and industrial AC and refrigeration equipment have to keep records of service calls and amounts of refrigerant added. Last but certainly not least, when we're talking about the Clean Air Act and EPA requirements, is a discussion of penalties that are in the Act. There are, in the case of violations that can range from failing to report to falsifying documents, or worst, knowingly releasing CFCs and HCFCs into the atmosphere, penalties can range up to $25,000 per day per violation. And in addition, it's important to note that people who turn in violators can receive awards of up to $10,000. All of these awards and punishments are carried out in federal court. since this is a federal regulation that we're dealing with. If CFCs are gone, essentially, and HCFCs are going, the question is, what are we going to do for refrigerants? The first hope, and the most promising, is to use HFCs. You remember them. They're the ones with none of those nasty chlorines attached. They have instead fluorines only. They have zero ozone depletion potential, a 0 dP, but they do have some global warming potential. And so they are not a permanent solution. While we search for even more permanent solutions, we have to find out how to use what we can. Of all the HFCs, HFC 134A shows the most promise as a replacement. It's a single molecule compound, that is, there's only one refrigerant in the liquid, and it's very similar in pressure, temperature, and efficiency characteristics to R12. So you say, well, gee, let's run out and replace all the R12 systems with HFC 134A, but stop, don't do that. Instead, we have to face up that there are some real differences. There are some incompatibilities with existing oils, and there are some performance characteristics that are different. So in order to replace or use HFC 134A in an existing system, you really need to have the specific information and guidance from the manufacturer. HFC 134A is not a drop-in replacement